Hello students. Hello and welcome to this video. In this video, we will solve question number 181 to 190. The links to download the PDF will be in description. As well as at the end, I will show you how you can download and maintain updated copy. And I will also show you my question answer website, which I have created for you to ask mathematical questions. So without further ado, let's get started. Question 181 says that given that the fourth term in the expansion of 2 plus 3 upon 8x to the power 10 has the maximum numerical value, find the range of values of x for which this would be true. So fourth term is 10c3 to the power 7 3 upon 8x whole to the power 3, and t4 is 10c2 to the power 8 3 upon 8x whole square, and t5 is 10c4 2 to the power 6 3 upon 8x to the power 4. Given that fourth term has greatest numerical value, so t4 upon t3 would be greater than 1. We evaluate and we find that x upon 2 greater than 1, that is x is greater than 2. Now we solve t4 upon t5, we evaluate and we find that x is less than 64 upon 21. So x would lie between 2 and 64 upon 21. Question 182 says that show that the roots of the equation x squared plus 2bx plus c is equal to 0 are real and unequal, where a, b, c are three consecutive binomial expansions. These should be coefficients actually with positive integral index. So we let the binomial expansion be x plus y to the power n, and a, b, c be the coefficients of r as r plus 1 and r plus 2h term respectively. So a will be ncr minus 1, b will be ncr, and c will be ncr plus 1. Now we find the discriminant of the quadratic equation, that is 4b square minus 4ac, or 4b square 1 minus a upon b into c upon d. So we substitute the value of a, b, and c, and we evaluate. We get 4 ncr whole square times n plus 1 upon n minus r plus 1 upon r plus 1, which is greater than 0. Hence, roots of the quadratic equation are real and unequal. Question 183 says that if n is in the set of positive integers, show that 9 to the power n plus 7 is divisible by 8. So what we do is we write 1 plus 8 to the power n, we get nc0 plus nc1 into 8 plus nc2 into 8 square, and so on up to ncn into 8 to the power n plus 7. Now this 7 plus nc0 will be 8. So we add them and we take 8 out. We get 1 plus nc1 plus nc2 into 8 plus nc3 into 8 square, and so on, which is effectively 8 into an integer. Therefore, it is divisible by 8. Question 184 says that if n is in the set of positive integers, show that 3 to the power 2n plus 1 plus 2 to the power n plus 2 is divisible by 7. So for n is equal to 1, we substitute the values. We get 3 cubed plus 2 cubed, that is 35, which is divisible by 7. We let it be true for n is equal to m. So 3 to the power 2m plus 1 plus 2 to the power n plus 2 is 7k. Then we evaluate for n is equal to n plus 1. It becomes 9 into 3 to the power 2n plus 1 plus 2 into 3 to the power n plus 2, which is equal to 7 into 3 to the power 2n plus 1 plus 2 into 3 to the power 2n plus 1 plus 2 to the power n plus 1, that is 7 into 3 to the power 2n plus 1 plus 7k from this. 7k, and there should be 2 here. It should be 14k actually. Yep, it should be 14k. So it seems like a calculation mistake. So yes, it is divisible by 7. Question 185 says that show that no 3 consecutive binomial coefficients can be in GP or HP. So we take 3 binomial coefficients, NCR minus 1, NCR, and NCR plus 1, and we let them to be in GP. So NCR upon NCR minus 1 is equal to NCR plus 1 upon NCR. And we solve it, we get n is equal to minus 1, which is not possible. We let these to be in HP. So 2 upon NCR is equal to 1 upon NCR minus 1 plus 1 upon NCR plus 1, which leads to n minus 2r whole square plus n is equal to 0, which is not possible. With the typing mistake. So GP and HP both are not possible. Question 186 is that let n be a positive integer and 1 plus x squared to the power n is equal to a0 plus n(x) plus a2x squared plus a3x cubed, and so on up to a to n x to the power n. Show that a0 square minus a1 square plus a2 square minus and so on plus a2n squared is equal to an. We let n be quotient of x to the power n and 1 plus x square to the power n and quotient of y to the power n and 1 plus y square to the power n. Now we have 1 plus x square to the power n is equal to this given expression. We substitute x is equal to minus 1 upon x. We get x square minus x plus 1 to the power n is equal to a0 x to the power 2n minus a1 to the power 2n minus 1 plus a2 x to the power 2n minus 2 and so on up to a2n. Now a0 square minus a1 square plus a2 square and so on up to a2n square is equal to quotient of x to the power 2n in the product of these two, that is quotient of x to the power 2n in x to the power 4 plus x square plus 1. Now quotient of this is equal to quotient of y to the power n in 1 plus y square, where y is equal to x to the power 2, and that is equal to an. Question 187 says that let n be a positive integer and 1 plus x square is equal to the same expression of the previous problem. So that a0 square plus a1 square plus a2 square up to minus 1 to the power n is an minus 1 square is equal to half n times 1 minus 1 to the power n am. So we have this expression given. So we have proven in the previous problem that this is n. Now we put x is equal to 1 upon x square plus x plus 1 is equal to a0 to x to the power n, a1 x to the power n minus 1 and so on. Equating the quotients of same powers of x gives us a0 is equal to a2n, a1 is equal to 2n minus 1 and so on. This also follows from earlier result where we proved ar is equal to a2n minus r. And that's how a0 squared minus a1 squared plus a2 squared and so on up to minus 1 to the power n minus 1, n minus 1 squared plus minus 1 to the power n, an squared minus 1 to the power n plus 1, an plus 1 squared and up to a2n squared is equal to 0. And thus we find the half of the value, that is this half is equal to 1 by 2 an times 1 minus 1 to the power n am. Question 188 says that show that sigma 0 less than equal to I less than j, sigma 0 less than equal to j less than equal to n, ci plus cj whole square is equal to n minus 1 to the power 2n, cn plus 2 to the power n, where 0 less than equal to I less than equal to j less than equal to n. So we have this given expression where I varies from 0 to n minus 1 and j will vary from 1 to n. So expression is equal to n times c0 squared plus c1 squared plus up to cn squared plus 2 sigma, both the sigmas, n times ci cj. We expand this, okay? So once we have expanded this, we get this is equal to n times 2n cn plus this becomes c0 plus c1 plus c2 plus up to cn whole square minus c0 plus c1 squared up to cn squared, which is equal to n times 2n cn plus 2 to the power n whole square. This is 2 to the power n whole square, and this is 2n cn. So upon solving this, we get n minus 1 times 2n cn plus 2 to the power 2n. I went a bit fast here, so let's evaluate this. If you evaluate this, it will be ci square, and I will vary from 0 to n minus 1, okay? And cj square will vary from 1 to n, and then to ci cj. So you do that and you will arrive at this expression, okay? And these results have been taken from previous solutions as well. Question 189 says that show that same sigma, and the expression is I plus j ci cj is equal to n times 2 to the power 2n minus 1 minus half 2n cn. So we have this. So I will vary from 0 to n minus 1, j will vary from 1 to n, and clearly n minus I will vary from n to n minus 1 and so on up to 3 to 1, and n minus j will vary from n minus 1 to 0. We see that n minus j behaves as I and n minus I behaves as j. So we write this as sigma, both the sigmas, n minus j plus n minus I, c n minus j, c n minus I. So this becomes 2n minus I plus j, ci cj. Okay. Now this is equal to 2n times the sigmas Cij minus E. You see this I plus j will be same as E here. So now 2E is equal to 2n sigma Cij. And this we have evaluated earlier. So it becomes n by 2 C0 plus C1 up to Cn whole square minus C0 squared plus C1 squared up to Cn squared, which is equal to n upon 2, 2 to the power 2n minus 2n Cn. Question 190 says that show that 1 upon m factorial C0 plus n upon m plus 1 factorial C1 plus n times n minus 1 upon m plus 2 factorial times C2 and so on up to n times n minus 1 plus up to 3 times 2 times 1 upon m plus n factorial times Cm is equal to m plus n plus 1 times m plus n plus 2 up to n plus 2n upon n plus n factorial. So from the left hand side, what we do is we multiply with n factorial upon n plus n factorial and divide by that also. So this term we have taken out, and inside we have n plus n factorial upon n factorial and factorial C0 plus n times m plus n factorial upon n plus 1 factorial and factorial C1 and so on. So the terms inside become m plus n Cn and C0 plus m plus n Cn minus 1 and C1 and so on up to m plus n C0 and Cn. Now we know that 1 plus x to the power m plus n is equal to m plus n C0 plus m plus n C1x plus m plus n C2x square and so on. And 1 plus x to the power n is equal to m C0 plus n C1x plus n C2 and so on. So coefficient of x to the power n in 1 plus x to the power m plus 1 times 1 plus x to the power n is equal to m plus n Cn and C0 plus m plus n Cn minus 1 and C0 and so on, which is equal to m plus 2n Cn. Now left hand side is equal to n factorial upon m plus n factorial m plus 2n Cn, which is equal to m plus 2n factorial upon m plus n factorial times m plus n factorial, which is equal to right hand side. So with this, we come to the end of question 190. I think I went too fast. So if you have questions, let me know. Now to download the books, you come to my website, astrowork.org, and links 2, 3, and 4 are your algebra, trigonometry, and coordinate geometry books. The coordinate geometry book is also available in HTML format. So if you want to read online, you can read that. Since this book uses MathML, the best browser I can recommend is Firefox, because Firefox Math ML engine is quite mature. And also, you see the date is given here along with the book names. So when you download the PDF, it won't contain the date. You need to add the date manually. I cannot put the date in the PDF itself because it will make existing links invalid. Also, if you want to ask questions, but before that, once you have downloaded the book and added the date, you should come again after 15-20 days and see if a new version has been uploaded. And if a new version is there, you can download it. Also, the question on the website is JEE link. That is pundrika.astrowork.org. You can come here and ask me questions related to algebra, calculus, coordinate geometry, mathematics, probability, trigonometry. So if these subjects do not include your related question, then use mathematics as a general tag, and I'll be more than happy to answer your question. So with this, I will end this video, and I'll see you in the next video tomorrow with 10 more questions on binomial theorems. Till then, have a great day, stay curious, keep learning, and most importantly, enjoy.